I am the chair of the Education Committee for the NAPB, so pleasure to welcome you and thank you for joining. And it's my pleasure to introduce Dr. Dieter Mulitze as our webinar presenter today. Dr. Mulitze began his university studies in mathematics and computer science at the University of Waterloo in Canada, later switching to Guelph, where he completed his BSc in crop science. And while at the department, Dieter developed a wheat breeding software system on the IBM mainframe computer. He then completed his PhD from the University of Saskatchewan in plant breeding and quantitative genetics in 1983, where at the same time he also developed a software system for all the crop development center's plant breeding programs. His doctoral thesis was on estimating the number of genes and quantitative traits using computer simulation and data from bred wheat crosses. After a postdoc at ICARDA, he was appointed an assistant and then associate professor at the University of Nebraska in cereal breeding. And Dr. Mulitze founded Agronomix Software in 1990, and since then has had the privilege of training plant breeders from around the world. And so I welcome Dr. Mulitze, and we look forward to his presentation on Genovix and the analysis of plant breeding data. So before I turn it over to Dr. Mulitze, just a few ground rules. If everybody can keep their microphones on mute, that will help with the sound quality. And additionally, throughout the talk, we're going to have 4 opportunities for questions. So if you would like to write your question in the Q&A box at the bottom, I will keep track of those. And then at 3 breaks within the course of the webinar and at the end, I will try to get to most of those questions with Dr. Mulitze, and we will address those questions. And I'm sure if any are not addressed, you can reach out to him afterwards. So Dieter, with that, I will pass it on to you, and thank you very much for doing this for NAPB.
Right, thank you for the invitation. I'm really pleased to be part of it. Zach and I really enjoyed the NAPB meeting this year, and it's a great time, so glad to be here. So Genovix, our new system, and I'll go through the steps of analysis of really, it's more like the variety trials data, but which is really a key part of a plant breeding program. So hello everybody, it's good to meet you. So I'll turn my my video off here and then focus on the software itself, the first segment. So experimental design. Everyone knows about the randomized complete block design, I think, and I'd like to start with an experiment that I did while I was associate professor at University of Nebraska, and then I was over in Morocco actually. And at a 24 variety RCBD experiment, 2 reps, the 12 plots per range, 4 ranges, and it was when it was planted, it was kind of dry, and then as the months went on into like January, planted in November I think, and in January it became really dry. The station, we needed sprinkler irrigation. It was applied unevenly, and as I was watching it, I was thinking, this is not the right way to do things. Just breaks all rules of good experimental practice. Around that time, I learned about nearest neighbors analysis, spatial analysis, and that's something I've published papers on over the years and done a lot of teaching, reanalyzed a lot of even some seed companies' data. So I was tasked with breeding for the farmers in the dryland region and helping their sheep, their goats, to survive the summer, which would be very hot, and they would even eat straw, believe it or not, as well as grain. So here is the actual straw data from those times. And a good statistical practice is to look at the distribution of the data itself. Give you some ideas, is it RCBD analysis strictly valid or not, and begin to look. Now, of course, you won't do this with every trait, but yield is a really important one. So I'm going to go to analysis, go over here to visualization, chart type, and I'll first look at 3D surface. So we have the ability to to look at this data in 3D. Settings here, you know, range and row and all that stuff. I'll skip that. So I'll look now here at the data itself, the first thing. So I'm just going to zoom that up a bit, and then I will do the orbital rotation. So as I was walking along my plots, it was actually 12 rows, 12 plots together in a range, 4 ranges. And you see here the yield was kind of low. This was really the dry area, and this was the wet area. Actually, the irrigation pipe had a gap in it. I was standing there looking at, oh man, all this water's leaking out, and then the water pressure was such that it was really great over this part of the trial, but not over here. And the little red dots are actually the checks. So the first glance is there are probably big trends in here which will distort the final decision of the breeder, of anybody doing a variety trial. Well, statistically speaking, if we look at a box plot, we want to look at the variation of the trait across the reps. So we know that if some of the varieties are really disturbed across the reps, they're compared to others, there's something that's just not good. The air structure probably is not that random either. So you look at like this variety here, Anjac, quite a spread across the reps. Over here, Columbus, compared that to Augusta and Blue Boy, and even one here like Oasis. So Oasis seems to be pretty happy, nothing disturbing it. Why is that? So the first feeling is this, you know, there seem to be some trends really at work here, really impacting any breeder's final decisions. Then I'm going to go down to the contour plot. And a lot of people like heat maps, and it's really been very helpful, but I'm not totally sold on the whole idea. I think that a contour plot is actually better. So here you can see here, this was my dry area as I was watching the crop develop through the year. And see, this is low to high. And straw yield was the trait that was mostly impacted by this uneven irrigation. And so here is a more favorable area. Just about anything planted over here is going to do well. This is kind of the middle zone, and these plants are having a hard time. So you can imagine that position effect is going to be very important. Yes, if I had 6 reps randomized, probably it would balance everything out, but I only had 2 complete blocks. So that's as part of the problem, just only so much land. So anyways, from the visualization, we realize something is not perfect here. So I go to analysis, and I'm just going to scroll this up. Here the experiment is open. I go to analysis, and I could do the usual randomized block. I have a generalized linear models, but I'm going to do the nearest neighbors. And the trait here is straw yield and nearest neighbors. And for spatial analysis, you need to be sure about how many plots are in a range, because the whole idea is to identify which plot is next to which plot. And from there, the algorithm I use actually builds a large matrix, and we do a lot of differencing calculations to come up with the final adjustments. And we have actually, there's an adjacent residual, which is like an iterative covariance, and it uses the estimated trends until the difference comes to almost 0 or converges to 0. And Graham Wilkinson, Australia, back in the 70s, published a paper on the original second difference model. And I have that programmed here as well. And both give very similar results. They're both independently programmed, but the adjacent residual tends to be a bit smoother. So anyways, with all that, descending order, and they were serpentine, I then click and do the analysis. So the nearest neighbor's weight is 0.83. It goes from 0 to 1. It's a kind of a ratio of the residual, whether it's under nearest neighbors or RCBD. So the closer to 1, the more the trends. This tells me right at a glance there are huge trends. 22 cycles. until the differences converges to 1/20,000th of the experiment mean. I force it down to a lot of precision. So as we look down, here's kind of the dilemma for the breeder. So if you would just do a randomized complete block design, these are the means you would get, and these are the ranks. You would say, you know, this variety here is number 1, and this variety here is number 6. You would say this variety here is number 5. But in this analysis, and it's similar to later on what we'll look at alpha designs and that, and lattices and row and column designs, you get what's called an adjustment of the mean. So here, this variety here, so here's the size of the adjustment, here's the shift in rank. This is the important thing, just at a glance. I see here shift in rank of 12. So under a randomized block analysis, one variety would have been, this variety would have been number 16, but it's actually ranks number 4. And you go down here and you might say variety here, ranking 6, it's 21. Or this variety, you say for sure, if I'm taking the top 5, I would choose this one, but it's actually number 7. So okay, so we understand that, you know, there are some differences here. Which statistical model do you follow? Well, I'll scroll down a bit. Here's some of the ANOVA. And I see the CV goes from 16, almost 70% to about 7%, and this is really good. Heritability goes up to 0.773. That should make any plant breeder smile. It's broad sense heritability. That's what you like to see. So the more that the model explains, the better your inferences in the end. Smaller LSD, etc. And there are the multiple range values, so forth. And we come down, and this is the estimate of the trends. So if you remember the diagram, we had a dry area, and then it was wet area, dry area, and you see over here, the spike over here was very wet. That's exactly what we saw in the contour plot. So the analysis picked it up correctly and has done all these adjustments. And so the question is, or the reality is, if a variety was sitting here in the first rep or block, and here in the second block, we know the yield is going to be kind of low. And if it's sitting here in the first block and here in the second block, as some varieties did by chance, they're going to be among the higher yielding. So the goal of these nearest neighbors spatial analysis is to adjust all the means for the impact of the trends so that the breeder ends up with the most likely genetic ranking. That really is the goal. And as I scroll down, I see here the residuals adjusted for trends and then unadjusted and so forth. And that tends to be quite random. So you know that when everything is removed from the residual in terms of the trends, looks more random, that helps to kind of vindicate the analysis. And you could say, well, I kind of saw this in the field, this makes sense, I will take those results. So that's the first part of the story. The whole thing of a RCBD analysis, which was started by Ronald Fisher in, I think it was like 1930 or something at Rothamsted Station in the UK. And then over the years now, everything has moved, a lot of papers to spatial analysis, of which there are many. But this is one example that I think is quite helpful to get a better handle on field variation when it's there. So yeah, so I'll break there. That's the first break for some questions. I hand it back to you, Rob.
Thank you, Dieter. At this point, we've got 2 questions. So I'm not sure whether you can see them on your screen in the Q&A. The first one was a comment, nice visualizations. How do you load and analyze hundreds of locations? And maybe that's something you're going to get to next. I'll let you handle that, Dieter.
Well, we can analyze hundreds of locations because we have a I can open up an entire trial. Let's say I had 50 locations. It'll do each one in order. There's a tool for that. We have a tool up here under analysis. Where is it? Multiple analyses. I don't have anything loaded here, but we can actually load in all the experiments you have in a current year, put in the default model, and it will analyze everything. So that's the analysis part. For the visualization, you really need to look at each experiment in turn to kind of see what's going on. I could say that those visualizations could actually be saved as a bitmap and even linked into the database, because this software has the ability to actually retain images. So I could link an image to any plot or the experiment. So that's my answer on that one. I hope that's helpful.
Okay, thank you.
Yeah.
One more question before I let you get back to your second section. If you have wide pathways between the ranges, are you better off looking for east-west trends only in nearest neighbor?
Oh, yes. Yes. You are. Yeah. By east-west, I mean along the narrow dimensionality. So the plots left and right. Yes.
Yeah.
If you have wide pathways or wide alleys, as I also call them, there's a greater distance where you don't know what's going on. You can't estimate anything. So what I do is I clicked, you notice I clicked here both. The algorithm went in one direction, 12 plots wide, and then it said, okay, let's try the other one, north and south. So every plot had like three neighbors with it in one direction or two in the other direction, depending where it is. I have seen some cotton trials where the irrigation was up the field, the other way to the plots in the alleys, and that's where there was a strong trend north and south. So typically, it's the narrow dimensionality of the plots. And actually, Dr. Wilkinson in Australia back in the 70s concluded that probably 93 or 4% of all the variation is due to simply that one direction. So he's saying you don't gain a whole lot by going even two directional. So I hope that answers the question.
Yeah, okay. Thank you very much, Dieter. I'll maybe turn it back to you. And just a reminder to all attendees, please type in any questions at all that you have in the Q&A, and we will do our best to address them all.
Yeah. Okay, so let's go on to some more complex designs. So these are these randomized block experiments up here, but I do have also some incomplete block designs. One here I have what's called initial yield experiment, and if I just take a second here, you see the incomplete block numbers, and if I go to details, it tells me this is an alpha design. So in our system, we can generate the alpha designs. Those are the 0, 1, meaning the entries occur 0, like never together an incomplete block, or once and only once. So again, here's a set of data that I've simulated. So I go to analysis, new here, and so one option is the generalized alpha lattice, and the algorithm is all built in the software. Click here, here's the model, it's entry block and the incomplete block. And here, if I had a trial open up like 50 locations, I just analyze by location, click this box, and it does all 50 in a row, which saves a lot of time, going back to that first question. Okay, so then I go to Analyze, and there we are. Gives you all the critical components, including the somewhere there's the mu value, and so forth. So we see some efficiency to RCBD, 144.7%. So some gains there. But notice, you know, I always empathize this to people who are wondering a bit about nearest neighbors, say, wow, here's a variety of shifted 20. I don't know if I accept this, but this is an alpha design analysis. So here's a variety of shifted and ranked 20. You know, here's one that went 6 to 10. This one stayed at the top, interestingly enough. So anyways, the analysis is there and so forth, and the restructured ranks in the original data. So it's all built in. So if you want to go to more complex design, and then we also have the other approach is to use analysis by R. So we have a number of scripts written, which one here for a lattice test. And so this shells the data out, goes to the R package, Agricoli, and then here uses NLME. We also use do-by, and there's a few other routines for, in some cases, mixed model. So, and the numbers here, the means are the same as the algorithm that's within Genovix directly. And for people who want things like Bartlett's test of homogeneity and normality test and Shapiro-Wilk normality, that's there as well. So that's a more complex set of design, and will give you more precision. You can see some of the adjustments. So in theory, you could, though, come back and say, we're going to do this, going to do a nearest neighbors analysis. I go to nearest neighbors, and this happened to be 12 wide. This is a 72 entry. I think it was 12 by 6 was how it was set up. And then I can go and analyze it again. And you might want to compare the results. Here we see the ranks like before and the estimate of the trends. Quite a different story. But again, you may want to look at and decide which do you accept. So using this, you could analyze it RCBD. You probably want to do it as a alpha analysis, and they also have the ability for nearest neighbors with the residuals displayed. So what about a row column design? What if I want to do another direction of variability? So we have the row and the column. This is a 5 by 5. I click here. So this is a lattice square, almost. It's also a row column resolvable design, 25 entries. So I've got 5 columns, 5 rows, and 3 applications or blocks. So again, analysis, I have an algorithm in here. So I go to traits, I'll have grain yield, square rectangular lattice. There's the model. Now it's a bit different. We have entry, block, column, and row. So one more term in the model for more precision. If there are trends in 2 directions, this will show up. And here we see indeed the blocks are different. The entries, not as much as you could. Actually, I did a simulation here. I could simulate it more, but it will give you the analysis, will give you the adjustments. So if you want a 2-directional design, you can fit that in your field plan. That'd be another option. And something else that some people have asked for prior to the seminar is the whole thing on split plot experiments. So here I have nitrogen variety, which we can easily design in the system. So I have nitrogen at 100 K, 0, and 50 kilograms of nitrogen per hectare. And I have a number of different varieties. So those are level 2. So I have MP as the main plot, and SP is the subplot. So again, click analysis and choose the trait. And the system knows what class of experimental design it is, comes up with the model that's here, which you could modify and change. Or sometimes you want to do that for a split plot or a split plot. And then I click here and analyze like so. And you see the Metaanova table with the interactions, the other components, and the means and LSDs, and so forth. Yeah. Or what about a split plot? That also was requested. So we have, here I have early planting, and I have within the planting dates, I have the different levels of nitrogen, and then I have the different varieties. So I want to decide if I'm going to plant AC Beagle, really what is its best environment? Plant early, what level of nitrogen, etc. And similar like before, I click choose the trait. I could choose 20 traits here if I had them with one click. And of course, we see a more expanded model because our hypothesis testing is a bit more now. And we go like so, and all the terms are there. So you could put in a model with nesting interactions and define it and outcome the results. And another one is early generation tests. No, non-replicated. Yeah, that's the one I prepared. So this is actually a modified augmented design, but I'm going to use a moving means analysis. We don't have quite the MAD design yet functioning. So I'm going to go here to analysis. new, moving means analysis, trait, grain yield. So again, this is 1 rep, and we have control plots that are inserted. So the system will actually use the results, the impact upon the control plots, it was here 20 in a range, to determine what's the best analysis, the best algorithm. And it turns out it's, no, let me go back. I want to choose the best analysis here. It'll go through the whole series of algorithms. So the quadratic method, this actually was a Australian biometrician came up with this method, looking at each plot and then the 2 plots on either side and weighting about 2/3 of the difference with the nearest neighbors of the plot, and 1/3 just a bit away, kind of simulating the, if you like, the quadratic effect. And again, we see entry is adjusted. Here's the idea. This seems to be the trends in the field. This is actually some data that a friend of mine let me use many years ago, and there we see the trends in the field and so forth. And quadratic, the variance of the trends, what you want to see is the highest variance of the trends, lowest variance of the checks, to guard against overestimation or underestimation and so forth. So again, a lot of papers written in this area, but this is one tool with a number of methods available. So yeah, so that's the second break then. So what we've done is we've moved from a randomized block to a more complex class of design. So Rob, I'll give it back to you if there are any questions.
Great, thank you, Dieter. A couple of questions here. Can you link the methodology used in the output to Jupyter notebooks or another results sharing system?
Link the results. Oh, I can export them. Is that the question? Because all the results can be exported to Excel, to Agronomix system, and RCBD experiments. Where did I have my nearest neighbors one? So there we are. So don't know what happened there before. So all the analyses done, I can bring them up. So this is what I did here, and here I can preview, I can save as.
And over export.
Right? Yeah, I can export the whole thing as a PDF. The other thing too is you'll notice here that we have all the columns already here. So we got the grand mean, the check mean, the LSD, the CSV, all these things. Because a lot of times people in variety testing would like to have like a table of all the means with all the stats at the bottom.
Yes.
So yeah. So anyways.
Okay, that sounds good. If the people that are asking questions too, please keep them coming. And if you feel we haven't addressed your question, please reword it, and hopefully we can get it the second go around. I've got a question or two, if that's okay, Dieter.
Yeah, yeah.
So you had mentioned the R scripts in this last section. Can you add, or can the user add additional R scripts at certain points, or can we contact you to add those?
Well, there's 2 ways. If you have an idea for a script that analysis that you think would be amenable to a lot of people, we would actually put that right in the control in there. But yeah, there is a facility. That's the plan, to allow people to put in their own R scripts. So if we go to your tools, where's analysis, scripts. So we can see here the R scripts that we have so far.
Okay.
So the lattice test, this was the script here. So a person could go into the scripts and minding how the data is taken out of Genovix and pushed back in, and in the middle layer here, put in a number of other things for more visualization, other things you want to do, or you could actually import another script. Yeah, so that's the long-term plan. It's not totally implemented yet, but that's what we aim to do. Because R is quite a powerful package. We like to lever that for as many people in the community as possible.
Okay, that sounds good. I've got one more question here, and I had one along similar lines. I was going to save to the end. I'll maybe ask it now. But is this new version available now? And will current users of AGROBASE be receiving information on this version soon about how to transition to it?
This version is available now for the variety testing version. We have some clients working with it now. And into next year, we will be probably in January, February, we'll be finishing off like the seed inventory system, the last part of it. And then we'll be working on the migration tool. I'm not sure how many months that will take. So the goal is for the current AGROBASE users, they will just get a migration tool from us, and it will move the data from AGROBASE SQL into Genovix SQL. And then you basically open up the system and you have to maybe reorganize things a little bit, but the data is there rather than having to export and then import. Yeah, they'll be in our newsletters to our clients for sure.
Okay, sounds good. I'll maybe let you move on to the third section then. We've got just under half an hour left, Dieter.
Good, okay, we're kind of more or less on time. All right, so we've looked at single location analysis. I'm going to move on now to the trials. So here I have advanced yield trial, and simple example, 4 locations. Brandon, Morden, Portage, Winnipeg. Very familiar to anybody in Manitoba. Okay, so I've done all the analyses. Here's my grain yield, 4 locations. And when we click analysis, so I need to go click trial mean here, and so you see the interface is kind of like Excel. The tools at the top relative to what you want to do. So I clicked analysis. Now we're not going to analyze the experiment as a RCBD or whatever. Now we have the means. Now we get into the whole thing of G by E analyses. So, for example, we've got cultivar superiority, which was developed by biometricians. I think it was Lynn and Binns at Ag Canada, maybe 15 years ago. And I kind of liked the method. Maybe it was 20 years ago. Be a while. So let's say I look at grain yield, cultivar superiority, these 4, and 4 locations. And I click like so. Simple number. What it does is subtracts the mean of a variety minus the maximum mean, squares the difference, sums it all up. So if a variety is the highest yielding everywhere, the difference between itself is 0. Square it, it's 0. Sum it, it's 0. Divided by 2 times number of locations, it is still 0. And interestingly enough, I've analyzed data for some seed companies, and we found out that the cultivar superiority measures statistic gave us almost the same inference in the end as all this high-powered other multivariate analysis. So here we see Cody at 13.081. It's a small number, and we see Wilgie at 13.366. The only way to get a small number is if it is in fact high yielding and relatively stable. Compare this to a variety like Marburg 60, Nantest 102. So okay, that's our first inference, like what's got a future. Equivalence, for those of you who know the papers by Ricke in Germany years back, he just came up with the equations, fairly straightforward, for the G by E sums of squares for each variety. So what is a variety's total contribution to the instability, to the noise across a trial? And I have the percentages here. So we can instantly see that Aleppo is pushing almost 9% of all the unhappiness, so to speak, across the locations. And then we go down here to Cody, 0.84 again, as I expect. So we know it's high yielding. We know it has small G by E sums of squares. And now a variety could have a small sums of squares, but it could be low performing. So yes, very small fluctuation, but it's consistently poor, right? So that's what the breeder wants to avoid. So I move on, and I could choose combined ANOVA. Now in this situation, it's probably not. Oh yeah, I need the parameter estimates, which are down here. So what I do is I take the means, I take the squares, the sums of squares. I take the rep mean square, the residual, all that, and I reconstitute a complete combined ANOVA. And it gives me the overall analysis. Now, if you start with an RCBD, no difference here, but imagine if you did nearest neighbors in each location, and with many locations you have a lot of trends. You want to eliminate that. So what we do is we then build a combined analysis based on the best estimate of the means. That's really what this is all about. Or if you have done a alpha design analysis and you want to do a combined analysis together. So that's one very efficient way of doing it. So then I go back to Eberhard-Russell. Those of you who have been in the plant breeding game for many years probably know this comes out of the late 60s, where these guys, Eberhard and Russell, looked at the mean of varieties, regressed it on the mean of each location. So you see here the full analysis, and we go down and we see the beta in that. And the whole idea is to get a slope near 1 and a small sums of squares, meaning a small deviation for linearity. And we see again Cody's doing pretty good, you know, and so is Wilgie over here, small number, 7.16. Again, Fortuna also, but I know that Fortuna is not a great yielder. So that's that one. Something, this is an R package, that's Shukla's stability analysis. So for those of you who love numbers, here you go. And again, we notice Cody here, not significant, means it's not becoming unstable. Nothing much has happened to it. The sums of squares are 151 in this analysis here, very low. And you can see Wilkie as well, and Taro, and Garrick 79. And it gives you some numbers on stability and so forth, and more stats. And the last one that I'll look at is GG Biplot. So that's a really great tool. So it comes up on my screen here. I click continue. And those of you who are familiar with biplots, you'll recognize this tool. If I save this to a PDF, it expands it a bit more. So I'm going to go to biplot tools, establish a relationship among environments. So all I'm going to say in this situation here, if you had to drop a location, you wouldn't drop Brandon here. Maybe one of these two, you know, based upon the data set in this year. So there are a number of different good inferences from a GG biplot. But again, it'd be a whole seminar in itself. It's all available, is linked in with Genovix. So yeah, I'll only say that if I go down to preliminary yield trials, I've got down here I've got 2019. So I could bring up other trial means that have a lot more locations. System easily handles them. So here I've got best plot, best fit, and I think these are about 26, 27 locations. So we will do a head-to-head a little bit later in the webinar, and some of this data will come into play. So I'll leave it at that. Rob, I'll turn it back to you on the whole G/E thing and analysis of trials.
Thank you, Dieter. No new questions here right at the moment in the Q&A. So if anybody has questions, feel free to ask them. Can I just get you to outline some of the main differences between Genovix and the previous version of AGROBASE?
The AGROBASE database has 120 or 130 linked tables, whereas in Genovix it's considerably more. So it's a more relational system. The AGROBASE has has 3 main nodes for treatments, parents, and populations. And here, in this system, we all have them on one main node, and you can manage them. There are more linkages. Yeah, there are more, but those are the ones that first come to mind. You can see it's a more modern interface, and what we've done is gone to kind of like an Excel interface. So everywhere you click here, see like the ribbon control. this is very new. I think it's a lot of softwares like this, so it makes it easy to use. So those are the ones that come to mind.
Great. Okay.
Yeah.
Okay. Well, for the attendees, we're going to have one more section here, and then finish off with a round of questions. So you've maybe got 10 plus minutes here to get in any final questions about the entire webinar. So I please encourage you to do so, and I'll turn it back to you, Dieter.
Yeah. Okay. So far we looked at numbers, and well, what about visual things? So here again are the means from the four locations for these varieties. So I want to do a regression graph and a biplot. I'll take Cody as one, and we know that Wilgie is a good performing variety. Grandin had some possibilities, and I'll take a few here. I know these are somewhat lower yielding. Katepwa is not doing that well, and maybe I'll take these here. All right, and maybe this one here. So the means are stored. Then I go to analysis, visualization, chart type, and I'm going to go to regression. And what I'm going to do is choose the regression for grain yield. That's the trait of interest. And we have the settings here for color and that, and I go visualize. And here's a regression graph. Abrahart Russell was big on this, that kind of idea. So this is the mean of the different varieties and regressed on the mean at each location, like so. I often find when I work with people's data, if I go to quadratic with the grid line, especially quadratic, you'll notice that tends to give you more information. Yeah, you see the how it bends, quadratic fit. So where is Cody? Cody is the little triangle here. BRS. Grandin is up here. Yeah, Cody should be there somewhere. Can't find it at the moment.
Cody's kind of hidden behind the pink near the top.
Oh, yes. Yeah. Okay. Okay, Wilger is right there, and that was a good yield one. Okay. Yeah, it's right in there somewhere. Yeah. The whole idea is when you look at this, yeah, you can see the numbers and get all the statistics, but there'll be some varieties who are pretty good in the stress environment, and then they really take off under high yields. So if you did apply more nitrogen in that, it's going to really pick up on yield. I've seen some varieties that really drop off. You know, they'll come down like this, and then they really drop off when the going gets tough. So again, a lot to say in the picture here. So another chart type I'm going to just do is a biplot. This is really important, where you can have 4 variables at the same time. So I'm going to take average grain yield across the trial, test weight. Then I've got maturity, and I think I got protein. So that's the analysis. Some was near as neighbors, whatever, to clean things up. And then I go to settings, and yeah, I'll just leave it like this, I think. And then we go to visualize. So we'll see the checks in red, and we'll see here 4 traits. I wish I would have had this in my days as a breeder. So here is low yield to high yield, okay, and then low test weight to high test weight. So we know that this is probably the best quadrant up here, and the next best would be down here. So we see Katepra as the check. It's actually about the same yield capacity here as Cody. Grandin is over here. So how to put together the 4 traits? Well, protein is the color trait, right? I chose that one. So the darker the blue, the lighter from the dark to the light, the higher the protein. So Grandin, Katepwa got similar protein, whereas you see the dots here dark, this is lower protein. And then we have the size of the dot. Or yeah, so this is early. Let me see. Small is early. Yeah, so that's early maturing. Cody tends to be early maturing. It has good, decent protein among the high yielder, but not as great test weight as you would like. So the idea is, excuse me, you have these 4 traits that appear together. So biplot is a really powerful tool. Now, 2 last comments. It's more than just if you want to do a meta-analysis, you may want to include data not only from the plots, but the genotype. So we can link in the database any genotypic traits. So I have here generic marker traits. So 3 molecular markers, I've got the phenotypic data. Then I go down here to location, and I say, okay, I've got, for location traits, I've got altitude and soil type. Soil type as I go down, and altitude, and then the other one is experiment. Plot size and previous crop. So here's the previous crop. One was maize, one was soybeans, and canola. So I do have some clients with AGROBASE even who have done what's called ridge regression. They combined a lot of environmental, genotypic, phenotypic data together, built a model to help do some predictions. So the last thing is, okay, so we have a trial within 1 year, but what if, of course, we will have trials across years. Some entries come, some entries go, some are advanced, and so forth. So for that, I can go to analysis, and I can go to head-to-head, and now we'll mine the whole database. I'll go down to AC Baton as my long-term check, compare it to 4 varieties, and I'll run that one. And the summary is 4 genotypes, 56 locations, 54 experiments, 4 years, and I'm just looking at 1 trait. Here are the genotypes. I chose AC Baton and these 4. Here are the locations. Quite a few. Mine the database. Here are all the years. Here are all the experiments. And then here's the trait. A few options depending what you want to see in the final report. And then I go build. Basically query the database. So it's pretty fast. In a few seconds, I went through the whole database, mined out all the data, and then now we're going to analyze, and we want to do a paired comparison with probability against the long-term check. So then I go here to see all the values. They're all there, and all this could be at this point exported if you want, whatever. But we go to report. I'm going to do a 1-to-1, and it'll take a second to come up. So here we are. These are built-in reports. You could modify them if you wanted to. So ANZAC 56 versus AC Baton. Altogether, 54 paired comparisons, 70.32 over 71.41. And here's percent of control. Here's the variance, and not different. Although in 2020, kind of planning ahead, I simulate data for another year, it's actually better. And then we break down into the individual locations, of course, where there is an advance, you see the plus sign there. So again, the next variety, and this one did actually quite a bit better, and especially in that year as well. So that's the head-to-head. There's also other commands to query the database for other purposes. But when you're looking at pulling together data across years and across locations, that's quite important. So yeah, so I'll stop there. That's pretty well the topics going in for variety trials from beginning to end. Thank you, Rob.
Great, thank you, Dieter. Really appreciate you taking the time to do this. Are there any questions that anyone would like to voice at this point? At this point, I would be good with any of the attendees raising their hands, and I can allow you to verbally ask your question and or type them in the Q&A. Anybody have a question? provide a moment or two to raise your hand. You can do so in the participants box. Okay, we've got a few questions in the Q&A box. Can you use your head-to-head comparison to a group of selected checks instead of one singular check?
Yes, yes, you can.
Okay.
Yeah, so I selected one check, simple example, but I could have, let's say, 3 checks, and then I have 5 new hybrids, and I'll compare each one to each of those checks.
Okay. Next question is, can you use conditional formatting or color for any of the output tables?
Any of the output tables? You mean like final reports, or?
Yeah, like using conditional formatting in terms of color coding for setting a threshold on some criteria or some trait, or in the output tables.
Oh, output tables. Well, all of these experiments themselves, I have color coding right here. So I have a min and max already coded.
Okay.
So here's min and max of 1 and 9. I have one at 0, and if I go to details somewhere, here's all of the colors. So the coding's all built in. And in the report generator, which is a very powerful system, you can put a lot of conditions and functions in there, and you can make just everything aligned with color that you want.
Okay. Additionally, you could export to Excel and do conditional formatting there.
Yeah. Actually, these all I can go to print preview, and then I go to orientation, landscape, and if I put color in here, okay, go to options. Take this off, auto width, go down here. So I've got some color here, and I can actually save this to Excel, and the color will come with it. You can open up with all the graphics.
Okay, great.
Yeah.
One more question here, and if you have any others, please fire away. Can categorical data be analyzed?
Oh, yeah. And for that, there's a different kind of analysis. So I go here to, we have an R script, and that one is the Kruskal-Wallis test. That's for categorical data. So we've had this in for years, even in AGROBASE, because the disease scoring, if you're taking 1 to 9, you don't want to do just a regular ANOVA. The probability values will not be correct for the final analysis. So you use a Kruskal-Wallis test, and this actually will take out the ranks or the categorical data.
Okay.
Yep.
Excellent questions, everyone. We've got about 5 minutes left. So if you have any further ones, please ask away or raise your hand. I've got one more question here, Dieter. Are there any additional features for incorporating marker data?
Additional features.
Or can
Not
you
yet in this.
incorporate?
Yeah, we have more coming in the future. Right now, you can import all these marker columns. There is an index query command, so I can build a weighted index. So I can say these values. I can do correlations. And we have worked with our BLUP already. Just a matter of time to actually connect that in.
Okay, another question. Is there a post-harvest tool, or can we use pre-plant for field layouts?
I'm not sure of the question. Pre-plant? You mean post-harvest tool?
Good question. I'm not sure whether they mean in terms of seed inventory or, I mean, field layouts you can definitely.
Yeah, you can do field layouts. I mean,
Yeah.
I'm showing them right here.
Okay.
I can design. I can move anything around the field. I can have a field with 20 experiments and 1,000 plots easily.
Okay.
And then I come along here and I have a grid where I have then the harvester order number, and that could be serpentine up and down, planting order, whatever. The other approach is you design an experiment and you say it's not in a plan, but I know I have 20 plots wide in a range and it starts at range number 6 or whatever, and it does all the numbering. So I'm not sure if I'm answering the question, but there are tools to bring it in from a harvester, etc.
If that came from an anonymous attendee, if they feel like that question is not answered, please ask again. Another question here, Dieter, regarding the price of Genovix. How does it compare to AGROBASE, and does anything change on the tablet version?
On the price, you should talk to Zach, our sales guy. It's quite similar to the AGROBASE price, so it's not like a massive increase. It is newer technology, so there's a slight premium for the extra effort to deliver new technology to our current clients and future ones. And yeah, so just contact us for more information. The tablet, currently AGROBASE has AGROBASE, we have AGROBASE tablet, it's a Windows tablet. Right now, because a lot of places in the world prefer Android, we actually have an app and a whole system for collecting data on Android smartphone or the Android tablet. And we also have it running in iOS. Now, some months down the road, I'm not sure how long, we will actually have the Windows as well. So it'll be Genovix Mobile for Windows. And that will be similar to what you have now, where you can lay out an entire field and take all the data. A lot of the functionality will be there as well. It's proven itself over the last 10 years or so.
Okay. We've got time for one more question or two.
Yep.
Final. One of the last ones here. Does it use geospatial GPS coordinates or simply range/row?
It does use GPS. So if I go here to Agronomix, and I don't think I have the coordinates here for this one, but if I go to details, details is right here, and here would be the latitude, longitude coordinates in degrees, minutes, seconds, milliseconds, or however it's done. And then if you go to locations, and I open it up here, I can actually, if I have to bring that up, forget. Yeah, so here I can click and I can actually, so here's Lethbridge. So that's where Lethbridge is found, right here. So I can grab it on the map if you want to get this way, or if you go to, with your mobile in the field, you take the GPS coordinate of the first plot you're in, or anyone thereafter, but typically the first plot, and then when it's uploaded back into the database, that the GPS coordinate appears for the experiment. So
great.
Yeah. So it's there.
Maybe Dieter, with the last minute left here on the clock, why don't you provide your contact information and best place to reach you?
Okay, so our website is agronomix.com, agronomix.com, and you can reach me at my last name, Mulitze, Mulitze, and agronomix.com.
Well, thank you very much, Dieter. I really appreciate this, and thank you to all the attendees for joining. This webinar has been recorded. We will post it on the Breeding and Genetics YouTube channel that's associated with NAPB, and please look forward to future communication on our upcoming webinars. And thank you again, Dieter, and thank you for everyone for joining.
Thank you. It's a privilege to be part of this. Thank you.
Okay. Take care, everyone. I'll sign off.
Okay.